Okay, we're back on mixed law of cosines and sines and area of the triangles. This is part 2. So we have one more example in mixing the law of cosines and sines, and then we're going to go to some applications. So we want to solve for all the parts w, y, the measurement of angle x and the measurement of angle y. So I draw the triangle and I label the triangle WXY, and then I put in the appropriate pieces that you see, where the side WX, for instance, is 9. So then I set up my ratios where I know that I've got an angle 31, and I've got a side of 15 opposite that. So I'm going to set up the sine ratio, sine 31 over 15. And then I've got sine X, and then over 9. So sine X, then, actually I have it, should probably have it sine y here. I was using 2 variables, but we're going to use sine of y just to keep consistency here. So then I'm going to say y here and y here. Okay, so we get our angle for y then is equal to the sine y is equal to, let's write like this, is equal to 0.3090. So we get angle y then, and I want to be careful about these. Angle y turns out to be equal to, remember, sine inverse of 0.3. I get 18 degrees for that, okay? So 18 degrees for angle y. Now you have 2 angles, so it's easy to find out what angle x is. That's just 131 degrees, right? So we have one obtuse angle. WY is what we need to find now. So we've got 15. Now we want, remember, I can use the law of cosines for this. So I'm going to find this side, so it's opposite. I could use lowercase x for this because it's opposite big X there, capital X. So then I'm going to say, all right, x squared is equal to, I'm going to use the other side information then, 9 squared plus 15 squared minus 2 times 9 times 15, and cosine of the angle at x, which is 131. I'm going to scooch this stuff over a little bit. Okay, so I have all my information there. I'm going to solve for x. I'm going to get x squared. You might as well throw that all into a calculator. I get x squared is equal to 483.1359. And so it turns out I get x is equal to, something happened to my x. X is equal to 22. So I get 22 is the side. You got to watch out. This is lowercase x here, right? You really have to be careful with your x's and y's and so forth. So I get my 3 parts that were missing. I have my 2 angles and my side, and we're all set, all done, okay? All right, so now we've got some application problems here where I drew the diagrams on the side so they'd be kind of clear in terms of what you're doing. Cincinnati, Ohio is 540 miles due east of Kansas City. So I labeled Kansas City KC and Cincinnati is C. The bearing from Kansas City to Nashville, Tennessee is 64 degrees south, 64 degrees east. So you see the yellow line? I haven't, that's my due north, south, if you will. So I've got 64 degrees, and you see it bending towards the east to go to Nashville, capital N. The bearing from Cincinnati to Nashville is south. So if you look at Cincinnati, C, and look at the north-south, here's the south for the bearing. And you see I'm 29 degrees south, 29 degrees west, so it bends to the west. South, bend to the west. Find the distance from Kansas City to Nashville, okay? So we're going to use some information, but before we do, we're going to try to establish what's going on with the angles in here. So you see the 90 and the 64. That's a right angle because it's due east. Kansas City is west of Cincinnati. Cincinnati is due east, straight due east. So that's perpendicular to our north-south line. So what I can do is say, well, that's 90 degrees plus 64. I can subtract that from 180. 180 minus 90 minus 64 is then going to be 26 degrees here. And I'll do the same thing for the right-hand side. So 90 plus 29, and then subtract that from 180, and I would get 61. Okay, 61 degrees here. So then it makes it easy to find angle N. I would just say 180 minus 20, the quantity 26 plus 61, and I'm going to get 93 degrees. So now I've got my setup here. And you can see down below I have illustrated that with the sums, how they have to be equal to 180. Or you could simply say that, hey, that angle plus 64 has to be equal to 90 since we already have a 90 degrees. All right, So dealing with supplementary and complementary angles. Okay, find the distance from Kansas City to Nashville. So what we're going to do is we're going to set up the law of sines. Because, think about this. I have sine of 93 over 540, a complete ratio. So I can set that equal to sine of 61, and I can put that over x. Now it can be x. Now do you see what x is going to be? Look at where 61 is. That's the prize. All right. I want that side. So that's going to be my first x. So then x is equal to sine of 61 degrees. Now what I'm going to do is I'm going to scooch this out just a tiny bit. I kind of like to put the number in front. So remember, you're going to multiply. You're going to put the x over here, multiplying both sides by x. And that's going to cancel these x's, right? And so you want to get x by itself, so you're going to multiply by the reciprocal, 540 degrees over sine of 93. So remember, you have to watch out with your parentheses when you do this. You should get x is equal to, then 472.9, and that's in miles, okay? There you have it. There it is. There you go, all right? There's the answer to that one. Find the distance from Cincinnati to Nashville. So we're going to do the same thing. I'm going to hold the kids outside for this one. They're going to be like, what is she doing? I'm going to keep this going, the first one, and then I say is equal to. Now I need the other one, so I'm going to say I'm going to go from 26 because I want to get Cincinnati to Nashville. So you can kind of see that. Let me do this here. It's this one. So I have sine of 26 that I want to use, and I'm going to use that. I'm going to use that with another variable. I'm going to choose y. Okay, so this is going to be my y here, where I chose x to be over there. Okay, so I have this, and then I'm going to say that this is then y is equal to sine 26 on this side, and then I'm going to multiply by 540 degrees over sine of 93, and that turns out I get y is equal to 237 miles, okay? All right, now, the last one I should actually let you do a little bit of work with, because you can leave the same port, ship A sails 8 miles at a bearing of north 45 degrees west. So in setting these up, this would be a good one on your own to do, to think, and to complete. So I'm going to let you go here on part 2, and I'm going to let the students in the classroom. So you guys have a great day, and I'll see you when I see you.